Okay, this is Chemistry Podcast 6.2, and we're going to talk about converting between moles, mass, and number of things. So we want to know, how can we use Avogadro's number to do some conversions? Here's what we know. We already talked about that 1 mole is 6.02 times 10 to the 23rd particles. Particles can be, if you remember, atoms, they're molecules, or they're formula units. It all depends on whether it's an element, whether it's covalent or ionic. The atoms were for elements, this was for covalent compounds, and this was for ionic compounds. The mass of 1 mole can be found on the periodic table, and we practiced doing those already. The example that we have here is that 1 mole of carbon atoms would have a mass of 12 grams. And we're going to use dimensional analysis when we're solving these problems with Avogadro's number. The example we're given here is how many years is 5 times 10 to the 10th seconds. So remembering dimensional analysis, you always start with what you're given, and we're trying to get the units to cancel. So I set up my table like this, and I know that there's 3,600 seconds in 1 hour, 24 hours in 1 day, and then there's 365 days in 1 year. And I set it up like that so that my seconds cancel, my hours cancel, and my days cancel. I'm left in years, which is what they ask me. And when I calculate the answer, I get 1,585 years. So we're going to be using this table setup to solve these problems. What we're going to do is we have a little diagram here, and it helps you kind of figure out what you use to do your conversions. We say there's 3 different islands. There's the mass island, mole island, and particle island. Mass island is when you have grams. The mole island is when you have moles. And your particle island, that could be if you have atoms, molecules, or the formula units. So depending on your unit that you're given, you'll know which island you're on. You can tell that you're able to go from grams to moles, and you're able to go from moles to particles. You cannot jump from particles to grams, though. That's why there's this no swimming in the sharks. You can't jump directly from particles to mass. You have to go through moles each time you want to kind of moles is your central island. That's where you want to go through if you're trying to go from mass to particles or particles to mass. When you're using the molar mass, remember that's the periodic table, and there are always so many grams is 1 mole. That's what you're figuring out. That's your conversion factor when you're doing molar mass. With Avogadro's number, you're doing that 6.02 times 10 to the 23rd. There's a point there. Things equals 1 mole. So your 2 conversion factors are what look like that. And remember, this is from the periodic table, and this is just Avogadro's number. So we're going to practice using this diagram. I have a simpler one, as do you, on the paper for the note outline. So here it says, how many grams does 1.5 moles of zinc weigh? Well, the first thing I'm going to do is I'm in moles. So I'm here. And it's asking me about weight, and weight is a mass, it's grams. So I'm going to be going from here to here. I'm going to have to use the molar mass. So the first thing I want to do is look up zinc. If I look up zinc on the periodic table, I can see that it's 65.38 grams per mole. That really means that I have 65.38 grams of zinc is 1 mole. They're equivalent values. So I'm going to use that as my conversion factor when I go from moles to grams. I start with what's given, so I have my 1.5 moles of zinc. And this is just going to be one step because I can jump from here to here using the molar mass. So I'm going to take the 1 mole of zinc from the conversion factor, and I'm going to put it on the bottom, and then I'll put the molar mass on top. I do that so that the moles cancel, and then when I multiply them, I get 98.07 grams of zinc. That should make sense to you that we would multiply, because if I know 1 mole is 65.38 grams, I have 1.5 moles. So I have to multiply that by the mass of 1 in order to figure out what grams would be for 1.5. So I get 98.07 grams of zinc, and that is just a one-step problem. The next question is, how many moles is 5.2 times 10 to the 23rd molecules of water? Molecules, remember, are a number of things, a particle. So I'm starting here, and it's asking me about moles. So I'm going to jump right to my moles. One step again. The conversion factor is Avogadro's number. So that's that 6.02 times 10 to the 23rd, in this case molecules, is equal to 1 mole of anything. So when I set this up, I start with what's given, 5.2 times 10 to the 23rd molecules, and I do my table. I'm going to put the 6.02 times 10 to the 23rd on the bottom because I need the molecules to cancel. And that is 1 mole on top. So those cancel. I take the 5.2 times 10 to the 23rd and divide by 6.02 times 10 to the 23rd. Punch this into your calculator and make sure you get the right answer. A lot of times when we involve this exponent, we end up with an answer that's really big, and that's not right. So if you end up with times 10 to the 48th, you punched it in incorrectly. What you should get is 0.86 moles. That should be your answer. And again, that makes sense because this number of molecules is smaller than a mole, so I should have a fraction of a mole for my answer. The third one, how many molecules are in 2 moles of carbon dioxide? So I'm starting in moles, and they're asking me to go to the number of things, to molecules. So again, I'm going to be using Avogadro's number. Oops, that's a 23. And this will be molecules equals 1 mole. That's the conversion factor I'm going to use. That's the Avogadro's number conversion factor. I start with what's given. And I know that 1 mole has this many things in it. So when I do that, my moles cancel. I'm left in molecules, which is what they asked me for. And then your answer should be 1.2 times 10 to the 24th molecules. And there's your final answer for that one. Okay, next one. How many moles are in 88 grams of carbon dioxide? Grams is a mass, and they're asking me to go to moles. So again, one step. This time I'm going to use the molar mass, which is the periodic table. So if I look for carbon dioxide, I need to figure out its molar mass. Carbon has a mass of 12, plus I have 2 oxygens. Each oxygen has a mass of 16. So this is 44 grams per mole for the molar mass, which is the same as 44 grams equals 1 mole. And I write it like that so we can see our conversion factor. I'm starting with 88 grams of carbon dioxide. I want to put the 44 grams on the bottom and the 1 mole on top. Grams go away. 88 divided by 44 is 2 moles. Okay, last question. How many grams does 2.5 times 10 to the 23rd formula units of sodium phosphate weigh? Well, I'm starting with formula units, and formula units are a particle, so I'm starting here. They're asking me about weight or mass, so I'm trying to end up here, which means I'm going to have to go through moles over to the mass. So this one is going to take 2 conversion factors. I'm going to have to use Avogadro's number first, and then I'm going to have to use the molar mass from the periodic table. So the first thing I'm going to do is I'm going to add up the mass of this thing. So sodium phosphate has a mass of 3 sodiums, which would be 3 times 23, plus a phosphate, which is 31, plus 4 oxygens. And when I add all that up, I get 164 grams, and that equals 1 mole. because that's grams per mole, so that's 164 grams is 1 mole. There's my first conversion factor for Avogadro, or that's the molar mass. And then Avogadro's number is using that 6.02 times 10 to the 23rd. In this case, it's formula units, equals 1 mole. And there's my second conversion factor. So I'm going to take those. I'm going to start with what's given in the problem, 2.5 times 10 to the 23rd, formula units, and then I use Avogadro's number first because I need formula units to go away, and that's this conversion factor right here. So I'm going to put the 6.02 times 10 to the 23rd on the bottom, and I'm going to have 1 mole on top. This is formula units. Those will cancel. Now I'm in moles, and I need to go to grams. So I put the 1 mole on the bottom, and I put the molar mass on top, 164 grams. And then your moles cancel. And when I do all that math, I end up with 68.1 grams of sodium phosphate. All right, so that is our last practice problem on the podcast. We're going to do a lot more in class. It's really important that you almost memorize this and the steps because you won't be given this on a test. This is something you need to know and to be able to figure out. So molar mass, Avogadro's number, make sure you can figure out conversion factors for both of those and that you understand that moles is in the middle. You can go anywhere from moles, but you can only go 2 moles if you're in number of particles or mass. So moles is kind of the central unit where you can branch out and you can go a bunch of different places from it. And that's it. So a lot of practice in class with the periodic table and a calculator. Make sure you bring those and that you start figuring out that diagram and being able to use it.